So the next thing I want to talk about are Turing machines. And Turing machines are very similar to DFAs in the sense that they're able to take an input string and be able to determine whether or not that language is going to be accepted or rejected via a state diagram like the one on the left here and like a DFA. Turing machines add a lot of computational power because they introduce the control state, the head, and the tape. And the tape was something that gave me a bit of trouble, so I want to go over some of the exercises that help me to do that. The tape also introduces the idea of the blank spaces in the accept and reject state, which are part of the 7-tuple representation as opposed to a DFA's 5-tuple representation. So the question 3.5 just helped clear up a few things about how to actually execute these Turing machines. The Turing machines can jump from left to right, and they can move any amount of spaces. So that being so this question, like A, can the Turing machine ever write a blank space on the table? That just helps me understand how in this state diagram that they are able to do that, and how each step, you see some blank spaces being written in here, how each step is executed. And can a Turing machine's head ever be in the same location twice? It's just a bounds check saying, you know, if I'm on the far left and I want to move left, I'll end up in the same spot because I need to read something to the right of me. And can a Turing machine never contain just a single state? It's just, it can't, because there's an accept and a reject state, so just inherently there can't be only one state. So I want to go over two of the well, I did two of the state diagram exercises. I'll just go over one. And so essentially what you do is you take the language like W, pound W, and a W is any amount of zeros and ones. So if the input string is going to equal something in there. So we take a string like 10 pound 10, and we start at Q1, which is our start state, and we read something to the right of that, which is a 1. So we see this takes a 1, and it replaces that 1 with an X, which on the tape it writes an X, and it moves to the right. So, and we're in Q3. So now we're in Q3, we have our X, and we've moved to the right. Now Q3 reads in a 0, and it doesn't write anything, it just moves to the right. So now we're over here, X0, Q5, no, I'm sorry, Q3, pound 10. And now we read in that pound sign, move to the right one. Now we're in Q5, as it says up here. Q5 reads in an X, no, I'm sorry, Q5 reads in a 1, and puts in an X, and it moves to the left on the tape. So now we're in Q6, we're over here, and we have a pound sign on the right. We're going to keep moving left to Q7. The 0 on the right stays in Q7, moves to the left, reads an X, moves to the right, back to Q1. There we are. Q1 reads in a 0, puts in an X, moves to the right. We're in Q2. Now we're working this way, reading in a pound, moving to the right to Q4, and we're reading an X from Q4. Yep. Moving to the right one, still in Q4, reading a 0, replacing that with an X. You can see this tape is being marked off with a bunch of X's here. XX pound, Q6, XX. That reads in an X, moves to the left. Now we've got Q6 reading a pound, moves to the left, back to Q7, reads in an X, goes to the right, back to Q1, which reads in that pound. Now it's going to get to Q8, and it's got X's on the right of it, keeps moving to the right until we're in Q8, and all we've got is blank spaces on the right, which brings us to our Q accept state, which this does accept. So that's an example of a Turing machine working. You can see like example C has 2 pound signs, so we get over to Q5, and this actually, the rest of this is not right, but Q5 can't read in a pound sign, so that goes to a rejecting state if it's unable to read in any of the input. So I thought the state diagram was a nice way of moving around the tape and being able to see a more detailed explanation of how that worked. So I got a lot out of these exercises, and I'm happy with both of them being up here. I think I may have learned the most from this exercise.